You're a goat standing on the slopes of Mount Etna. It's a normal afternoon. Grass, sun, the usual business of being a goat. And then, for no reason any human could see, you turn around and walk downhill. Not wander. Walk. Deliberately, urgently, like you have somewhere to be. Within hours, the mountain erupts. This isn't a folk tale. This actually happened, and it's been happening for as long as humans have been paying attention. Animals going quiet, going strange, going somewhere else entirely, right before the ground opens up or the sky turns wrong. And for most of history we filed this under superstition, next to black cats and broken mirrors. But here's the thing nobody tells you, some of the strangest animal behavior on record lines up almost exactly with disasters that hadn't happened yet. And modern science is starting to take that seriously. So the real question isn't whether animals go silent before disasters. The evidence says they do. The real question is how they know. What are they sensing that we can't? And why, after thousands of years of watching it happen, are we only now starting to understand the mechanism? Let's start with the moment that made scientists stop laughing at this idea. December 26, 2004. The Indian Ocean tsunami. One of the deadliest natural disasters in recorded history. Along the coast of Sri Lanka, inside Yala National Park, a wave that killed over 200,000 people across the region tore through a reserve packed with elephants, leopards, deer, water buffalo. Human casualties in that park, 0 large animal deaths. Rangers who survived reported something they'd never seen before. Elephants moved to higher ground hours before the wave hit. Flamingos abandoned their usual low-lying breeding areas. Dogs refused to go outside. Not one, not a few. Multiple species, multiple locations, all reacting before there was anything a human being could see, hear, or measure with the naked senses. Now, one incident is an anecdote. But this pattern shows up again and again, across completely unrelated disasters, on opposite sides of the planet. The 1755 Lisbon earthquake. Historical records describe dogs howling and horses bolting in the hours before the ground shook apart the city. Chinese seismological records, some of the oldest continuous animal behavior logs in the world, describe the same pattern before the deadly 1975 Haicheng earthquake. Snakes coming out of hibernation in the dead of winter. Rats fleeing buildings in broad daylight. That specific event is actually one of the rare cases where authorities evacuated a city based partly on animal behavior, right before a massive quake hit. Thousands of lives were saved. So we have earthquakes, we have tsunamis, and it turns out we have volcanoes too, which brings us back to that goat on Etna. In 2020, researchers actually strapped biologging sensors onto animals living on the slopes of active volcanoes, and it wasn't just goats. Ecologists working with the Icarus project, which tracks wildlife movement using satellite tags, found that animals near Etna changed their movement patterns hours before eruptions, consistently, measurably, on a timeline too precise to be coincidence. Okay. So the behavior is real. It's documented, it's cross-species, it's global. Now let's talk about the part that actually matters. Why? What are animals detecting that seismographs sometimes miss entirely, or catch only seconds before the damage starts? The first theory, and probably the most solid one, is P waves. When an earthquake happens deep underground, it doesn't produce one shockwave. It produces two. P waves, primary waves, travel fast and arrive first, but they're subtle, low amplitude, easy for a human to miss entirely. Then S waves arrive, slower, and those are the ones that actually shake buildings apart. That gap between P wave and S wave can be seconds, sometimes tens of seconds. Not much time for a person. Plenty of time for an animal with senses tuned differently than ours. Many animals, especially ones that live close to the ground, snakes, elephants, and others with sensitive feet or trunks, are exceptionally good at detecting vibration through the earth itself. Elephants in particular can pick up seismic signals through specialized receptors in their feet and even their trunks, feeling frequencies traveling through solid ground long before those vibrations would ever register to a human standing in the same spot. So when the ground starts humming with a P wave that we can't perceive at all, an elephant might already be walking away. But seismic sensitivity doesn't explain everything. It doesn't explain the flamingos abandoning their nests hours in advance. It doesn't fully explain animals reacting before some quakes even produce a detectable early wave. So there's a second theory, and this one is stranger. Infrasound. Infrasound is sound below the range of human hearing, frequencies so low we simply can't perceive them as sound at all. And here's the thing, large-scale geological events, earthquakes, volcanic eruptions, even massive storm systems, generate enormous amounts of infrasound, sometimes hours before the visible event occurs. Elephants communicate using infrasound routinely. So do certain birds. Pigeons, remarkably, can detect infrasound frequencies so low that scientists still don't fully understand the biological mechanism involved. If a disaster is essentially broadcasting a warning signal in a frequency range that only some species can hear, then of course it looks like magic to us. We're simply not tuned to the channel. Then there's a third mechanism, and this one gets into genuinely strange territory: electromagnetic and chemical changes in the environment itself. Before some major earthquakes, researchers have recorded shifts in the electrical charge of the atmosphere, and even changes in groundwater chemistry, gases released from stressed rock deep underground seeping upward before the rupture ever occurs. Some scientists propose that certain animals, catfish being one of the most cited examples throughout Japanese seismological folklore and modern research alike, are sensitive to these electromagnetic disturbances in water and soil. Japan actually funded formal research into catfish behavior as an earthquake prediction tool for decades, treating it as a legitimate scientific question rather than superstition. So, put it together. Seismic sensitivity through the ground. Infrasound below human hearing. Electromagnetic and chemical shifts in the air and water. None of these are supernatural. They're all real, physical, measurable phenomena. What's not fully understood is the extent to which different species combine these signals, and how consistently they respond. That's the honest scientific answer, and it's a little unsatisfying, because we want a clean single explanation. Nature rarely gives us one. Here's the irony sitting underneath all of this. We built an entire civilization around instruments. Seismographs, satellites, barometers, atmospheric sensors, billion-dollar early warning networks. And in some documented cases, a herd of goats or a flock of flamingos responded to a disaster faster and more accurately than our multi-million-dollar detection systems did. Not because animals are smarter than our technology, but because their bodies are the technology. Millions of years of evolutionary pressure built sensory systems finely tuned to exactly the kinds of signals that precede death from the Earth itself. We spent decades building machines to replicate senses that already existed, walking around on four legs, mostly ignored, mostly dismissed as instinct. And that raises an uncomfortable question. How many disasters throughout history did animals warn us about, and we simply weren't watching? How many howling dogs, how many fleeing snakes, how many silent forests were dismissed as coincidence, right up until the moment the ground opened? For most of human history, we didn't have seismographs. What we had was attention. Villages that survived earthquakes for generations sometimes weren't lucky. They were paying attention to something the rest of us have trained ourselves to ignore. Modern science hasn't solved this completely. Animal behavior alone still isn't reliable enough to serve as a formal early warning system on its own. False positives happen, and not every disaster produces the same signals every species can detect. But research groups around the world are now combining biologging data from tagged animals with traditional seismic and atmospheric sensors, trying to build hybrid systems that catch what our machines miss and what our instincts have forgotten how to notice. So the next time you hear that dogs went quiet before an earthquake, or that flamingos left their nests before a wave came in, don't file it under folklore. File it under senses older than seismographs, tuned by millions of years of survival, still working quietly in the background of a world that mostly stopped listening. The ground has always been talking. We just needed something with better ears to translate it. And maybe the real disaster isn't that we can't hear the warning. It's that so many of us forgot we ever could.